Okay, so we're going to be calculating average rates of change today. Whenever you see rate of change for something that's linear, I want you to automatically think slope. So the average rate of change is the same thing as the slope of a line that's connecting 2 points. So again, think the same thing when you see those. You're going to read each problem and determine the coordinates. So you have to decide which one is the x and which one is the y. Remember, slope is the change in y over change in x. So remember, y is our dependent variable, x is the independent variable. So as you read this, you need to determine which variable is x, which is y, and then plug it in to the slope formula. And then also just a reminder here, they've got the slope formula written, and we've already done it some this year, but to make sure that you remember, to find the slope between any 2 points, we're going to use y2 minus y1 over x2 minus x1. Another thing that they want us to really focus on is the units. So we're going to give context to our answers, talking about what the slope actually represents. So here the y value was words, the x value was minutes. So when I simplify the fraction, 560 over 16 was 35. That's 35 words per minute, words over minute. So you're getting an idea of how quickly Tammy can type. So include those units in our problems today. So as I look at number 1, it says the population of Austin, Texas in 1990 was 472,000 people. The population in 1980 was 346,000 people. So first, identify the 2 variables. What are the 2 things that are changing? We have the year is changing, and we have the population is changing. So then we got to figure out, does the year depend on the population, or does the population depend on the year? And it's the second one there. Population depends on year. Remember the little hint, time is almost always an X. And if you have money, it's almost always a Y. So here we have time, talking about years, so that's going to be my X values. So when I look here, my 2 points, my 2 coordinates, I have 1990 and 472,000 is my first order pair. And then I have 1980 and 346,000 is my second order pair. So now plugging in to the slope formula. Y2 is, again, we can do it either way we want to. Let's just make this one Y2. So that's going to be 346,000 minus Y1, which is 472,000, over X2 is 1980 minus X1, which is 1990. So again, you can plug that straight into your calculator. If you do, the numerator should be negative 126,000. The denominator should be 10, or negative 10, excuse me. And so that would give me 12,600 when I simplify that. And again, you could probably put that straight in your calculator to get that number. So positive 12,600. And then what were my units? Well, the top, the numerator was people. The denominator was years. So what is this number telling us? The slope, or the average rate of change? There's about 12,600 people moving into Austin, Texas every year. So what they want us to do there, they want us to actually give context and give a sentence. So I'm going to type this in because I know, let's see if I can figure it. There we go. So for my sentence here, to give it context to make it all make sense, let's say from 1980 to 1990, the population of Austin, Texas, increased at an average rate of change. So I'm going to abbreviate that AROC of 12,600 people per year. And maybe let me move that so we can see all of it. There it is. So from 1980 to 1990, the population of Austin, Texas increased an average rate of change of 12,600 per year. So all the problems are very similar. You have to determine the independent and dependent variable. You have to plug into the slope formula, and you have to simplify. So what I want you to do is I want you to work on the rest of the problems today in class, and then I want you to turn this in on your Google Classroom. So if you want to work it out on paper, take a picture of your paper and upload it, that's fine. If you want to work on the worksheet that's attached, like using Cami, that's fine too. I don't care how you want to do it. But that's what we're doing today, is calculating average rates of change from word problems.